Find the currents and voltages immediately after the switch closes. The switch closes at t equals 0. All voltages and currents are 0 prior to the switch closing. At the instant of switch closing, t equals 0 plus, some voltages and currents remain unchanged. The current voltage relationships for the capacitor and inductor indicate what remains unchanged. This is the current voltage relationship for the capacitor, the rate of change of voltage across the capacitor, multiplied by the capacitance, is the current through the capacitor. If the voltage across the capacitor could be discontinuous, then the current through the capacitor would be infinite at that instant. Therefore, the voltage across the capacitor is continuous. In other words, the voltage across the capacitor does not change instantaneously. This is the current voltage relationship for the inductor. The rate of change of current through the inductor, multiplied by the inductance, is the voltage across the inductor. If the current through the inductor could be discontinuous, then the voltage across the inductor would be infinite at that instant. Therefore, the current through the inductor is continuous. In other words, the current through the inductor does not change instantaneously. This is time t equals 0 plus. The switch has just closed. The voltage across both capacitors remain unchanged from 0 volts. Looks like a short. Looks like a wire. The current through the inductor remains unchanged from 0 amps. The inductor looks like an open at this instant. The problem reduces to a simple DC circuit at this instant, at t equals 0 plus. The inductor is still there, and there will be voltage across it. Both capacitors are still there, and there will be current through them.